27. A height of so this is typical optimization question, right? Relative rates.
Yeah.
Okay, let's do this.
Nice.
So the height is 10 inch. And the length is increased at the rate. So you can see it has X, it has Y, okay? dx over dt is 2. dy over dt, you have to be careful over here. You have to write down negative. And when the length is, so when the length, which is x, equals to 8, the width is the y, equals to 6. That makes sense?
Okay.
And the volume of the box is changing. So we want to calculate the volume. Volume is xy times h, right?
Yes.
And h is 10, so this is 10xy. Now dv over dt will equals to 10 times dx over dt times y. Yes? Plus x times dy over dt. Okay? That makes sense?
Yeah.
Now dx over dt is 2. And the y is 6. And x is 8. And dy over dt is -4. So this is 10 times 12 minus 32. That makes sense?
Yeah.
That makes sense, right?
Yeah, that's just solving for volume.
Yes. Okay. Yeah. You list the formula and then you can do the product rule. And you plug in this given conditions. All right. You have no trouble for this one. 27, 28. Let me put my glasses. If this limit is L, and L is a finite number, then it follows that. So this is saying your limits at this location exist, but you didn't say that FC also equals to L. So you cannot say that you are continuous, you know?
Oh.
You didn't give me the value at this location. So
but isn't it, it
wrong.
says it is an infinite number.
No, it's a, they didn't, so look.
Oh, finite. I said, I thought it said infinite.
Not this, okay. This one, they didn't say fx equals to L. They didn't give you this condition, all right?
Okay.
This is not given. This is not given. You cannot say this equal, okay?
Okay.
And you say this guy is defined. No, I don't know, okay? I don't know if it exists. I really don't know from the given condition. And F prime, no. You even don't know if it's continuous. How you can come up with a derivative exist? That doesn't make sense. So none of them, okay?
Okay.
To have the derivative exist has to be number one, continuous. Number two, the derivative on the left equals the derivative from the right. None
Yeah,
of them
'cause
apply over
the
here.
teacher said that, what's it called? He said that the exam is going to be be similar to our last test.
Okay.
And then on the last test, I got what, a 90.
Oh, okay.
I don't know what I missed though. I thought I got it all right.
Okay.
But I'm
Let's
trying
see
to
here.
pull it up.
26. So I'm going to pull up this one. This is also relative rates question, right?
Yeah. Mm-hmm.
Okay. Now let's do over here. Okay. So it's a ladder. And this guy is leaning against the building.
Mm-hmm.
So that guy, okay?
Yes.
And this is the building. And this is my floor, okay?
Okay.
And this guy is moving away.
Yeah.
So this is dx over dt equals to 3, right?
Yeah.
When the foot of the ladder is 10 feet, so that means this x equals to 10. The top is moving down at the rate of r feet per second, right?
Mm-hmm.
Okay, moving down. So let's do this. We can say that guy, yeah, is 26.
Mm-hmm.
So x squared plus y squared equals to 26 squared, right?
Mm-hmm.
And then 2x times dx over dt plus 2y times dy over dt equals to 0, correct?
Mm-hmm. Correct.
And then I'm going to divide it by 2, okay? So let's divide it by 2. Okay. Now, dx over dt is 3.
Yeah.
And x is 10,
Mm-hmm.
correct? Yeah. And then this is the y value. Well, we can calculate the y. 26, so square root. So 26 squared equals to x squared plus y squared, right?
Correct.
Okay. Yeah, if you remember, we have those kind of Pythagorean theorem, 3 number pairs,
Mm-hmm.
5, 12, 13. So this is be 10, 24, 26, right?
Yeah.
All right. So if that guy is 10, that guy is 24, right?
Mm-hmm.
So the y is going to be 24. Does this make sense to you?
Yeah.
I don't want you to use this guy, you square, you do this, and then you do that, and then you minus, and then you square root. Oh my gosh, that's too slow. You want to do this level, okay? Yeah.
Do you mind going over 2 questions from my test?
Sure, you can send me, okay?
Yeah, I'm gonna send it to, because I'm
Phone.
sending it from my
Yeah, you
phone.
can, yeah, you send, give me good quality pictures, okay?
Yeah, I only missed 2.
Sure.
And
Let's see.
both my answers are pretty close. I didn't get the answer, but I was close.
Okay, let me finish this one.
All right.
So this is 10, this is 8. So R equals to 10 over 8, 5 over 4. All right.
Okay.
Yeah. that guy. Let me see what question you have. Okay.
Do you see it?
Yeah. I have
just
to
only the
drop
two that are incorrect.
Sure. I have to drop it to my iPad because I cannot see those small things. My eyes is not working well.
Okay.
Because I use electronics for too long time.
I thought eyes don't get worse when you're older.
No, that's not right. That's not true. Okay, let's try.
Yeah, it
This
says
one.
if that's second derivative.
Let me still do this, okay?
All right.
Yeah, this size I can see it. In my phone, that size, I'm not able to read it.
Since I got a 90 on my test, I think I won't do. I think I'll do pretty decent on my exam.
That's true.
Because he says almost almost the exact same, not the same question, but the same format of questions.
Yeah.
Okay.
F. This is the first derivative, right?
No, second derivative.
Oh, really?
Yeah.
Okay. Okay. Oh my gosh.
Yeah.
Okay. Second derivative equals 0. Then F has a point inflection. This should choose sometimes. This should choose sometimes. The reason is because, let's see here. For example, fx equals to x to the power 4, right? Oh, this one. First derivative is 4x cubed. Second derivative is 12x squared. Yes? And of course, that guy equals to 0, right? Does fx, this guy, is 0 is not the reflection point. You know? The reason is because, look, x to the power 4, if you draw it, if you draw the graph, x to the power 4 is something like that, right? Very flat over here. Yes?
Yeah.
This one, you cannot see that this guy has a reflection point at 0, you know?
It's inflection.
This one is not called the reflection point.
It says inflection.
Yeah, inflection point. This one cannot be called. The places, if you want to call some point as the inflection point, you have to say this, okay? You say here, your f prime c, okay, equals to 0, and your position, this is, and this are different signs, you know?
Okay.
They switch signs, all right? Yeah, if they switch from both sides, then this point is called the inflection points. For example, y equals to, for example, y equals to x cubed, you know?
Yeah.
Y prime is this. Y second prime is 9x. Yes?
Yes.
At 0, you know, So if it's on the left, yeah, if it's on the left, for example, when x is less than 0, this guy is less than 0. When x is bigger than 0, this guy is bigger than 0, right?
Mm-hmm.
And at x is equal to 0, this guy equals to 0. Yes, you see the signs switched. Then this point is called the inflection point. Does that make sense?
All right, so how do you find inflection point?
Inflection point, you have to follow this procedure.
That's
you
on
want
the
to find
the next
Yeah.
question is inflection.
Oh, okay. Hold on. Let me get the
Because I thought I did it correctly.
this one, right? This
Yeah.
one here. Okay.
Mm-hmm.
Let me just do this. This is not your fault because this is something very tricky. Okay.
That's not good. Then I should have got it right. I wanted because it was a progressive test.
Yeah, I think we covered this in summer, but we didn't do it too many times.
Yeah.
Let's see here. Eh?
You printed the same one.
Hold on.
That's not the one. Da-da-da. Yeah, that one. Nope. Yeah,
Yeah.
that one.
So strange. I want to, hold on. Let me do this.
Yeah, it's right there. I see it.
Okay.
Nope. That's not the one.
Really?
It's the one to the right. The third one. Yeah, that one.
All right. We made it. Okay. They ask you at which value it has a inflection point.
Yeah.
So yeah, so this is the place we want to check, y prime equals to 20x cubed minus 5x to the power 4. Y second prime equals to 60x squared minus 20x cubed. Right? So this one you do 20 and then x squared. And then 3 minus x. Correct?
Yep.
And it's right that you make this equals to 0. And then you make x equals to 0. Or 3.
Wait, is 0 not included because it says x squared?
Yes.
So it's a bounce?
Yes.
So it doesn't cross over, huh? Oh my god.
Because when x is on the, so
I could have gotten 95.
So you see this guy plus, yeah, on the right, yes, that's bigger than 0. And you are choosing a very close neighbor points of 0 on the right. So this is positive, that's positive. This guy is bigger than 0.
So like, okay, so let's say let's say if I do the derivative, right? And I do it twice and I get something like 3 minus x.
Yes, if you
squared.
have those things, yeah, if you have those 4 or 2 even thing,
yeah,
that guy is not going to be your inflection points.
And it'll be the same if it's you see where it says 3 minus x. So if that was squared, that's same. Right. It'll be the same thing.
Yes.
So if that
this
was
one because
power,
so this will be yes. Right.
Well, I won't miss that again.
Yeah. So to be safe, you do something like this, Yeah. To be safe, you do something like this. So this one is not. This one is yes.
Mm-hmm.
Mm-hmm.
Okay.
Yeah. Inflection, you have to check your second derivative have to switch the sign. Otherwise, you stay on the same side. This is not called a inflection points. Inflection points is something like this. From concaving down to concaving up, or from concaving up to concave down. Okay?
Okay.
That makes sense?
Yeah.
Very good.
Because this
Yeah,
test
good.
replaced my lowest test grade, right?
Uh-huh.
So my lowest test grade was like a 70. So then it replaced it with a 90.
Wow. You can make it even higher.
I could have got at least a 95, but I guess I didn't.
Yeah, it's good. You pick up those questions. Don't let it go because those questions could happen again.
Mm-hmm.
Very smart kid. You know how to study now. That's good. Very proud of you, okay?
Yeah.
Doing this same type of study habit for college, you know?
Mm-hmm. At least the good thing is my test is my last test of the week.
Oh,
So I have a lot of time.
now let's do 30.
Okay.
F prime X. I just want to confirm with you. So in December, you will not have 2 classes, right? Next 2 weeks, you have no class, right? Your
Yeah.
mom said.
Yeah.
Okay.
Next 2 weeks. Yeah.
Okay. And in January, you will resume the class, right?
Yeah. Mm-hmm.
Yeah, because I need to confirm the students for the spring semester.
Yeah.
Okay. This one, let's do it. You have no problem to do this.
So we do chain rule, right?
Yes.
So first we pull out 3. So it'd be 3 sine. No, it'd be 3, yeah, sine squared 4x.
And
then times what, 4?
A?
No, then it's cosine.
Yes.
Cosine cube
And
4.
yes. You made it. Okay. Good job. So that's this guy, correct?
Yeah.
This one is increasing. So we want to do the derivative, right?
Yeah. That's the one where you make a number line, right?
Mm-hmm.
And then you see if it's like plus, minus, minus, plus.
Yes. That's right.
Yeah.
Okay. So we treat this one as those polynomial, you know? Yeah. Remember?
Yes.
We do this in algebra 2. You can do the sign chart. You can do the polynomial. Polynomial is a fast one. Okay.
I just do the chart just so I can see it, like the number line.
Yeah. So this is 0. This is a 4. Okay. And leading coefficient is negative. So if it's positive, you're going up. You're going up, right? Yeah. And then this guy is going down. So you have to do this. Cross and then wiggle through. Does that make sense?
Wait, so I thought it wiggles at 0.
Oh, yes. This one. Good job. You improved so much.
Well, because
That's
I
really
need to do good on my exam.
Oh, you do so good now. Wow, you pick up everything I teach you before. That's really good.
That's only because of my exam. I have to think more. Okay.
Yeah. Hey, hold on. I think I do the opposite one because this is to the power of 4. The leading coefficient here is negative, so it's an even one. So I do the wrong one. I do the wrong direction. You see what I mean? It should going down. It should open down. You see what I mean?
Oh, okay.
You see this guy? Yeah, because I put here as the positive, you know. Yeah, I would rather rewrite this. Okay.
Okay.
Yeah, this leading term is negative, and it's even. Even, you remember, even is like that, right? Even is like that. And this guy is negative, so it's going to be like that. And this is wiggle through, and this is cross.
Okay.
If it's 2, then this guy is a bounce point, you know? Okay. We want it to be increasing, so positive. Who is positive? 0 to 4, right? Correct? Yeah, bigger than 0, correct?
Yeah.
Okay. If you want to do the sun chart, you can do it, okay? You can say, all right, I'm going to do a sun chart. That's 0, that's 4.
Yeah, or I just plug into a calculator and then he can't even tell.
Come on, this is easy. You see?
I know.
When this guy is between 0 and 4, that's positive. Yes? Correct? That makes sense? Okay. 1 second question. Go ahead. How much? Which one?
That's a 1 second question?
Yeah, of course.
What?
Come on, you can do it. Go.
How do we do these?
That's the same order. What are you thinking?
Oh, it's that type of question. Now I
No,
know.
you cannot do this wrong anymore, okay?
It's a negative 1/2.
Okay.
Wait, we wrote down all the rules, right? Like same
Yes.
order is just
Yeah.
you know,
Yeah.
if the top's bigger than the bottom.
And believe it or not, we learned this at least more than 10 times, you know?
Yeah.
Okay, same order, that guy, okay? Now, this guy. Wow, they give so easy question.
No, this is hard. Okay, let's see. The domain. Oh. What is the domain? All real numbers.
What?
No. All what? All except for 4, right?
Yes.
Okay.
Go ahead, do it. You do yourself, and I do mine, and then we compare.
Okay, just letting you know that's second derivative.
Yes. Mhm. This guy is that guy times that guy, correct?
Yeah.
And then this guy derivative is the product rule. That's negative sine x squared times 2x, and then times this 2x, and then plus this guy times this guy derivative.
Yeah.
Oh, we have a none of above choice, right?
Yeah.
I was wondering which one.
Wait, is there an answer key? Let me see. Yeah. What's his look like? What question are we on? We're on question
It's 34.
34. Question 34 is A.
Really?
Dun, dun, dun.
Oh, sorry. I didn't see this guy. We take a x squared out. Yeah, we take a 2. Wait a moment. No, it couldn't. If I take a 2 out, and then this becomes to cosine x squared minus 2x squared. Oh yeah, that's right. Okay. I don't know why my eyes doesn't work.
What happened?
I don't know. My eyes hurt so much recently.
Yeah, you know what are you wearing glasses while you take class?
No, I don't wear glasses. Today it hurts so much. I had to wear glasses.
You're supposed to wear
That's true.
blue light blocking
Yeah.
glasses. It makes it less. It actually makes it better.
Yeah, because my screen time is too much a day.
Or you know what you can do is I'm pretty sure there's a setting where you can decrease blue light.
Right. Yes. Okay.
Yeah. Genius.
Go to this one.
Limit as it approaches 3. Doesn't that not exist?
What? Is that way I teach you?
There's a hole there, right?
Yeah. So you have to do the simplification.
Then it's 1 over x minus 3.
Which one you choose?
Does not exist.
Oh,
I was right.
That's by lucky.
No, I knew it. I'm a genius. Okay.
36.
Yeah, his answer key doesn't show any work. It just tells us the answer. Okay.
Mean value theorem. Oh, well, you are looking for those guy who is not continuous on the interval, right? Yeah, this one is okay. This one is okay. That one is okay. That one is also okay. The only guy you have trouble is this guy.
Yeah.
Because 0 is inside here, right?
Where? Oh, yes.
0 is between this and 0 doesn't exist.
Yeah.
Now this one.
From the negative direction.
Yes. Now negative direction, you can say from the left to approach to, okay? So this is what? Positive or negative?
Negative.
Negative 1, right? Okay. Because this guy can be simplified as that guy.
Mm-hmm.
If this guy is
Oh, I
continuous,
hate these.
then if this guy is continuous, then the derivative exists. No. Continuous is a prerequisite condition for being able to be derivative, but doesn't guarantee you to be derivative, okay?
Okay.
If f prime c equals 0, then f has a local maximum or minimum at c and fc. Maybe, but let's go through others until we confirm, okay?
Okay.
This one, well, you already see a smart kid, okay? You will work on that question, so this one you know this is not, right?
Mm-hmm.
Correct?
Wait,
That's
so no, for C, if it was the first derivative, would it be true?
Wait a moment. You say this guy equals 0, then has an inflection point? No.
Is it possible then?
It has no relation, okay?
Okay.
First derivative, second derivative, the function totally changed.
Oh, I see.
You cannot make that conclusion.
Oh.
Okay, yeah, that doesn't make sense. If f is differentiable at x equals to c, then f is continuous. Yes. If it's differentiable, then it has to be continuous at that location. Okay?
Mm-hmm.
Yeah. Differentiable is very hard to meet. If it's differentiable, it's going to guarantee it is continuous at that location.
Yeah, this question's gonna be very useful. You know why?
Yeah.
Because I bet you this is gonna be on the it's gonna be on the test.
Yes.
And it's gonna be always, sometimes never. And because on this one it says true or false, then I know most of these are not always. So it's only sometimes or never.
Yeah,
I can
very good.
down
Very
my
good.
choices.
For the E, no. The reason is because I'm going to draw you a beautiful function, okay?
Wait, so could we go over from like A to E? Like, can we go over like if it's like sometimes or never?
Yes,
Because like number C is sometimes.
sure. So let's see here. This guy is continuous. So I'm going to give you a counterexample. I make an absolute function,
Mm-hmm.
you know?
Yeah.
This is continuous, yes. That guy derivative exists? No. This is negative, this is positive. This one will be wrong, okay?
So that's never.
No, this is sometimes. Oh my gosh. This is sometimes.
Okay.
All the other functions, those continue, beautiful sine, trigonometry, all satisfy this, you know?
Okay.
All this kind of function does satisfy A, right?
Mm-hmm.
So this is called sometimes. This one, derivative is 0, have a local mean or maximum at C. Let's look for a counterexample, okay? So I'm going to draw a graph. This one, we have to do those kind of candidate stat test, you know?
Mm-hmm.
They will not guarantee to be a local mean or local maximum until you do your candidate test. Yeah, from here, you cannot really tell. And this one, we already know, right? This one, we already have it. So this one is sometimes, yes?
Mm-hmm.
Okay. And E is not correct because what? If you including those edge, yes?
Mm-hmm.
Yeah, those mean or max, has to go through those candidates test. This one is not possible. Does that make sense?
Yeah.
Yeah, double check your answer key. I don't want to make something wrong over here.
I mean, it doesn't, on our answer key, it doesn't tell us if it's sometimes or never. It just says what the answer is, which is, let me see. Yeah, it's D.
So E is not correct. This is also sometimes, okay? E is also sometimes. It is because you could have the mean or maximum. You see here, your maximum value is on the edge, you know?
And
this is from A to B, right?
B is what, never?
No, that's also sometimes.
Okay. You didn't put
B
an
is
S,
also.
so I thought it was never.
This is also sometimes.
Okay.
This is always. Okay, right? That makes sense now?
Yeah.
Okay. I feel like you know the correct way of study for college already. Let's see here. Do the differentiable equation. No, implicit method. So you are going to do the derivative. X derivative is 1 times y squared plus x times y squared derivative is 2y times dy over dx. And then minus 3 and then plus 4 times dy over dx equals to 0, right?
Yes.
And then y squared minus 3 plus 4 plus 2xy times dy over dx equals to 0, okay? Then dy over dx is equals to 3 minus y over that guy, yes? That makes sense?
Yes.
Very good. Now let's do 40. So we want to find out the critical number. Yeah, make the G prime T, okay? Product rule. T derivative is 1 times 7 minus T plus T times the other guy derivative. 1/2 7 minus T to the power negative 1/2. And then times negative 1. Yes?
Yeah.
Nah, this is a chain rule, right? Make it equals to 0. So square root of 7 minus T equals to positive 1/2 T times 1 over square root 7 minus T. Yes?
Yes.
So 7 minus T equals to 1/2 T, right? 14 minus 2T equals to T. T equals to 14 over 3. Yes? But critical number doesn't mean your first derivative equals 0, because it means both. It means that guy is 0. It means that guy doesn't exist. Who makes that guy not exist? It's a location where the denominator is equal 0. So that's 7 minus T equals to 0. Correct?
Correct.
Oh, but they said T less than 7. So this will not work, okay? So don't worry, right?
But 7's not even an option.
So it's C, right?
Yes.
Yeah, those questions are tricky. It's not hard question, but it's easy to make mistake.
Mm-hmm.
Let me just make sure everything is correct. Yeah, that's right.
Mm-hmm.
Yeah, that's right. Okay.
Okay.
That makes sense? Critical number. Critical number, not only the guy equals 0, but also that guy doesn't exist. Okay.
Okay.
Yeah. Find those critical number or find this increasing or decreasing is apply your first derivative. Okay.
Mm-hmm.
Find your concave up, concave down is your second derivative. Okay.
Okay.
Your inflection is using your second derivative. Okay.
Okay. Critical number is like first derivative.
Yes.
Concaves and inflection are second.
Yes. Extrema. Extrema is using the first derivative. Okay.
Okay.
Extrema is looking for your candidate's test. So do the first derivative. Make equal 0. So x is positive 1 or negative 1, right?
Mm-hmm.
But you want to be careful because you want to check. If you want to get the mean or max, you have to check your second derivative, right?
Mm-hmm.
And this gives you a 6x. When x equals to 1, that is positive, right?
Mm-hmm.
Yeah, it's positive, it's going to be concave up, right?
Yeah.
X equals to negative 1. That's concave down, right?
Yeah.
So x equals to 1, this is the mean, right?
Mm-hmm.
This is max. Does that make sense?
Yes.
X equals to 1. X equals to 1, y is 1 minus 3, which is negative 2. X equals negative 1, this is negative 1 plus 3, which is positive 2.
Mm-hmm.
Correct? 我在上课，赶快出去。 Okay. So annoying to have a baby. Let's do this. This is a mean value, okay?
Mm-hmm.
And this is the maximum value.
Mm-hmm.
Who is the answer? Who is the answer choice you want to choose?
Okay, that's min and that's max.
Okay,
And
so which one you choose?
I need to choose B.
Good job, smart choice.
Oh. You know what the answer is? For number 41?
Uh-huh.
It's A.
Really? No. Oh, hold on. Sorry, distraction, okay. Because we haven't checked the edge, okay. You know, we haven't checked the edge. This one is those questions for the example you want to see over here.
Mm-hmm.
That one, right?
Yeah.
Okay. Yeah, when you are focused on something and somebody else come to disturb you, then you lost your track.
It's okay. I still made a smart choice, like you said. Smart choice, Alex. You got it wrong.
So we want to put here. Okay.
Mm-hmm.
Yeah. So we choose A, right?
Yeah.
Okay. This one. Well, oh my gosh, my glasses. Okay, let's do the the conjugate. Okay. That guy, we can times that plus that, okay?
Mm-hmm.
So the top one becomes 2 4 minus x squared minus 4, okay?
Mm-hmm.
Then this is canceled. So negative x, and then this is gone, right?
Mm-hmm.
Correct?
Correct.
And then here is 0. Here is not 0, so that's 0, right?
Mm-hmm.
If your denominator is not 0, your numerator is 0, then that's 0, okay? Now, for this one, if you can manipulate with the formula we learned in Algebra 1, that's easy question. Cancel. So this is 1 over 2.
Mm-hmm.
Correct? Make sense?
Mm-hmm.
Okay. For the C. Oh, did you learn the L-Hospital rule? I teach you in summer, right? Did you learn the L-Hospital rule?
Yeah. Mm-hmm.
Yeah, so for the C, we are going to do the L-Hospital rule, okay? This is infinity, this is infinity, so that's infinity over infinity. So we are going to do the derivative for the top and also for the bottom.
Okay.
Yes.
Yes.
And then do one more time. 2 over e to the power x. And now this is infinity, this is 2, so that's 0, right?
Yeah.
Okay. Come on. 1 second, go. Time out.
2.
What's the answer? Yes. $43.
I don't
How you
know.
want to do this one?
1. 2.
You,
2. There's a 3.
Well, you do correct. That is 1. That's right. Okay. But I want you to know why.
Isn't the only rule I know is like sine squared x over x is 1. Something like that. Oh, sine x over x is 1.
Yeah. The reason is because this guy has a limit from -1 to 1. This guy go to infinity, right?
Mm-hmm.
Yeah. And so this guy will be what? 0. So this is 1. That makes sense?
Mm-hmm.
this guy, limit. That's sine x, right?
Yeah.
Over cosine x, and then x, you know?
Mm-hmm.
How much is this?
Zero.
What?
No, it's 1.
This guy is 1. This guy is 1. So that's 1, right?
Yes.
Okay, very good. Last one. Limit this. Well, in summary, I gave you way more harder question than this.
Yeah.
Go ahead, try.
Mm. Two.
Seriously?
Yeah.
You see what I'm writing down, you know? You remember the double angle formula, do you?
Yes.
Be the good boy. You has to be, okay? My baby always, every day sing the song. Be the good girl. You has to be, but no, never. And how do you want to do it over here? So I'm going to do this guy. 5 times 2 is 10 over 3. But I'm going to make this guy to be 2x. And then do this as 2 times sine 2x. Okay?
Yeah.
That makes sense?
Mm-hmm.
And this give you a 1, right? That guy gives you a 1, right?
Yeah.
If that guy gives you 1, who should be your answer?
Mm. 1.
What?
Oh, wait, my bad. 20 over 3.
I'm pretty sure your teacher will include this type of tricky questions in your test. All right?
Yeah.
You want to go through those questions. Without looking my notes, I'm going to upload, but please do yourself first and then check with my notes.
Mm-hmm.
Okay? Yeah.
Okay.
So let's see. Yeah, we can cover all of this in the next class. Oh, we don't have more class, right?
No.
All right. Yeah. If you have a question, you can send me messages. All right.
Okay.
Okay. I'll see you in January.
All right.
Okay. Bye-bye.
Bye.